Hey there, and welcome to this explainer. If you're a junior developer looking out at the horizon, kind of scratching your head trying to figure out exactly how to map out your career and your skills for the future, well, you are in exactly the right place. Today, we're focusing on building your 2026 Backend Development Roadmap. Think of this explainer as really the essential first step to structuring your entire learning journey. Because let's be honest, the world of backend development can feel incredibly overwhelming, right? There are endless frameworks, constantly shifting trends, and just a massive mountain of jargon. But we're going to cut through all of that noise today. We're going to break down these complex back-end concepts using simple, everyday analogies so you can build a rock-solid foundation. Let's get your 2026 roadmap started.
Okay, let's dive right into this. We're going to go step by step. We'll kick things off with the 2026 roadmap basics and then move through 4 essential steps. Step 1 is programming languages. Step 2 is database systems. Step 3 is API architecture. And finally, Step 4, DevOps essentials.
So, kicking things off with the 2026 roadmap basics. Before we generate your complete career path, we really have to start at square one. Imagine you're building a house. You wouldn't just go and pour concrete without a blueprint, right? So right now, we need to define the broad strokes of your backend knowledge. Think of the topics we're about to cover as the 4 main walls of your house. Miss one and, well, the roof collapses. By organizing your learning into these distinct buckets, you're making sure your 2026 roadmap is balanced, comprehensive, and ultimately highly hireable. All right, let's move to step 1, programming languages, and see how this builds. This right here is the very first layer of your backend journey. It's choosing your fundamental building material. You've got 4 essential languages to research for modern backend development: Python, Java, Go, and Node.js. Python is kind of like wood. It's flexible, it's super easy for beginners, and fantastic for getting a structure up quickly. Plus, it's wildly popular in data and AI right now. Then you have Java. Java is like steel-reinforced concrete. It is the absolute gold standard for massive enterprise-level skyscrapers. It might take a bit more effort to set up initially, but man, it is incredibly robust and scalable. Then there's Go, or Golang, which is like modern, lightweight titanium. Built by Google, it's designed for high performance and handling multiple tasks at the exact same time, making it incredibly fast. And Node.js? Well, Node is basically like finding out you can use the exact same building tools for the inside of the house as you do for the outside. It lets you use JavaScript, the language of the front-end web, on the back end as well. Now, as a junior developer, your goal is definitely not to learn all 4 of these poorly. No way. Your goal is to research them, pick the one that aligns best with your local job market, and really master it. Which brings us to step 2, database systems. Once your language is chosen and those walls are up, you need a permanent home for your application's data. Think of it like a massive storage warehouse down in your basement. And this brilliantly illustrates the primary architectural choice every junior developer has to make: traditional SQL versus NoSQL. Imagine a highly organized, super strict corporate filing cabinet. Every single piece of paper has a specific folder, every folder has a required label, and everything must be perfectly formatted before you can even store it. That's a SQL database, or a relational database. It's rigid, it's predictable, and it's perfect for complex relationships, like, say, a banking app, where an exact dollar amount absolutely must link perfectly to a specific user account. On the flip side, imagine a massive, flexible storage unit, where you can just toss in boxes of literally any shape or size. You don't need a strict label up front, you can just store a document as is and figure out the exact structure later. That's a NoSQL database. It's incredibly flexible and great for massive amounts of unpredictable data, like a social media feed, where one post is text, another is a video, and another is just a poll. Understanding exactly when to use that strict filing cabinet versus the flexible storage bin is a huge milestone for your 2026 roadmap. Moving right along to step 3, API architecture. Okay, so right now your application is completely isolated. You need APIs, which are essentially the doors and drive-through windows of your house to actually connect to the outside world. First up, we have REST. Think of REST like ordering food at a traditional drive-through. The restaurant has a fixed menu, right? If you order combo number 1, you get exactly what comes with combo number 1. The burger, the fries, the drink. You can't ask them to fundamentally change how they package the whole meal. You get the standard response. Then you have GraphQL. GraphQL is more like a high-end custom buffet. Instead of a fixed menu, you tell the backend exactly what you want. You say, hey, I want 1 slice of tomato, 2 pickles, and a scoop of mashed potatoes. And the backend gives you exactly that data. Nothing more, nothing less. It is so efficient. But listen, whether you use REST or GraphQL, you absolutely need authentication. Authentication is basically the bouncer at the door checking IDs. It makes sure that the person asking for data is actually allowed to see it. Grasping how to build these communication endpoints, and obviously how to secure them, is vital for your success. And finally, we arrive at step 4, DevOps Essentials. So the crucial point here is that you've written the code, you've set up the database, and you've secured your APIs. But here's a little secret that a lot of junior developers miss. Getting that code onto the actual internet is the other half of the battle. To round out your roadmap, you have to pull in details about Docker, Kubernetes, and cloud providers. Have you ever heard a developer say, "Well, it works on my machine," when a program crashes on someone else's computer? Docker completely solves this. Docker is literally a standardized digital shipping container. You put your code, your database, and your APIs into this container, you seal it up, and it's going to run exactly the same way anywhere on Earth, guaranteed. But what if your app gets super popular and suddenly you need, say, 500 of those shipping containers running all at once? Well, that is where Kubernetes comes in. Kubernetes is like the port manager or the air traffic controller. It automatically manages, moves, and monitors all your Docker containers to make sure the app never goes down. And finally, cloud providers, like AWS, Google Cloud, or Azure. These are simply the plots of land you rent. Instead of buying expensive server computers just keep in your closet, you rent space on massive computers owned by these companies to host your shipping containers. Actually grasping this deployment pipeline is exactly what separates a junior dev from an incredibly competitive hire. So you now have the 4 foundational walls of your backend house. But remember, this is just your empty notebook. These 4 pillars, languages, databases, APIs, and DevOps, they serve as your baseline checklist. Your immediate next action is to run a fast research search on the web. You really need to pull in the latest 2026 trends, tutorials, and sources for each of these categories to fill in the missing details. Once you've done that, you can compile all those sources and map out a crystal clear picture of your exact learning path. We have covered a massive amount of ground today, transitioning these complex technical concepts into the architecture of your very own learning journey. But the real work starts the second this explainer ends. So I'm going to leave you with this. Looking at languages, databases, APIs, and DevOps, which of these pillars will you run a fast research search on first to kickstart your 2026 roadmap? Pick one, dive in, and start building. Thanks so much for joining me on this explainer, and happy coding.